Okay, so just to kind of drive the point home that I was trying to make at the end of the last video, um, for example, if you had a statement that said something like sine inverse of 1/2 equals b, right? So if you're looking at something like this, it means that sine of b is equal to 1/2, okay? And that b is between negative pi over 2 and pi over 2. Okay. And there's only one possible value of this, right? There are infinitely many angles b such that sine b is equal to 1/2. But only one of them lives between negative pi over 2 and pi over 2. And that angle would have to be, pi over 6, right? So b would have to be pi over 6. Okay, so sine inverse of 1/2 is pi over 6 and no other angle, right? On the other hand, if you had a statement that said cosine inverse of 1/2 equals b, this means that cosine b is 1/2, and it means that b is between 0 and pi. Okay, the domain restriction is different for cosine than it is for sine. This is the restriction for cosine. This is the restriction for sine. Okay, but again, only one angle. There are infinitely many angles b such that cosine of b is 1/2, but only one of them lives between 0 and pi. And that one would be pi over 3, right? So b would have to equal pi over 3 in this case. Okay, and the same thing goes for all of the other 4 trig functions, right? They all have their kind of standard restrictions that are listed on that chart in your book on page, I think it was 259, right? So you can see what the standard restrictions are. So let's practice doing that a little bit. Okay. So I just want to practice evaluating a bunch of these things. Cosine inverse root 3 over 2. Okay. Cosine inverse root 3 over 2. So we're looking for an angle so that cosine of that angle is root 3 over 2. But we need for the angle to live between 0 and pi. Okay. So the answer there has to be not 1/2, sorry. It has to be pi over 6. Pi over 6, right? So cosine of pi over 6 is root 3 over 2. And pi over 6 lives between 0 and pi, right? So it matches satisfies both of those criteria. Okay. Let's do cosine inverse negative root 3 over 2. So this time we're looking for an angle such that cosine of that angle is negative root 3 over 2. And again, we need for the angle to live between 0 and pi. Well, if we're getting a negative output, we must be in quadrant 2, right? We must be in quadrant 2. So I'm thinking that it's the angle in quadrant 2 that has pi over 6 as a reference angle, okay? So that would have to be 5 pi over 6, okay? Okay, so I'm doing most of this in my head. If you need to write something down, you could, right? So you could say, well, like if it's helpful for you to draw a picture, then draw a picture, right? You're thinking, okay, I know I've got to be in quadrant 2 because cosine is negative in quadrant 2. And I know from the work I did in part A, right, that the reference angle here has to be pi over 6. So what I'm asking is, what is that angle right there? Well, it's got to be pi minus pi over 6. That's 6 pi over 6 minus pi over 6, right? 5 pi over 6. Let's see if we can do the same thing for sine. So I'll let you think sine inverse root 3 over 2. Give the video a pause, see if you can figure it out. Okay, so I'm thinking this one's got to be pi over 3. All right, that's the only angle that lives between, in this case, has to be between negative pi over 2 and pi over 2. It's the only angle that lives in that interval such that sine of the angle is root 3 over 2, right? And then let's do sine inverse negative root 3 over 2. Okay, so give the video a pause, see if you can come up with it on your own. Okay, now this one's a little tricky. If you're thinking like 2 pi over 3 or something, it's because you're working with the wrong restriction. You're not supposed to be between 0 and pi anymore. You're supposed to be between negative pi over 2 and pi over 2. And besides that, sine of 2 pi over 3 would still be positive root 3 over 2. And you're looking to get a negative root 3 over 2, right? So you don't want to be in quadrant 2. You actually want to be in quadrant 4, right? You want to be in quadrant 4 between negative pi over 2 and 0. So you want to be in quadrant 4. But the reference angle should still be pi over 3. So I'm just thinking it's probably going to be just negative pi over 3, okay? Negative pi over 3. That angle is between negative pi over 2 and pi over 2, and sine of negative pi over 3 should be negative root 3 over 2, okay? So that's going to be what does the trick. We'll do some more of this in the next video, but before I go on to the next video, I do want to point something out, notation-wise, and that is that instead of using this inverse sign, sometimes we use arc, A-R-C. So in other words, something like, cosine inverse of x is the same thing as arc cosine of x. All right, sine inverse of x means the same thing as arc sine of x, right? And so forth, right? Same for all of the trig functions. It's like trig inverse of x is the same thing as saying arc trig of x. You can just replace trig with like any of the trig functions, right? So we use that arc notation sometimes, but they're interchangeable. They mean exactly the same thing. Okay, so I'm going to start another one. We'll do some more of this kind of stuff with inverse functions.